desktop audio here. Let's see, I'm not sure the audio is working. Let me know if it does work. Oh wow, Twitch seems to have a huge lag. Okay, I think I have something like at least a full minute of lag from me talking to Twitch. I'm not sure if YouTube is the same. Same thing roughly, maybe a bit less. Okay, a bit less on YouTube, it seems weird. Usually it's Twitch being a bit more reactive and YouTube being always delayed. Okay, so I guess we'll start soon. Just checking if the chat works correctly. Yes, seems fine. Here. Okay, this all looks good. The chat too. Yeah, I think. Yeah, okay, perfect. Alright. So yeah, let's get to it. So hi everyone. Today I wanted to continue a pull request that I started on MathOptInterface a couple months ago. No, 1 month ago roughly now. Which is about being able in MathOptInterface to evaluate if a given variable, a given value for a variable, belongs to a set or not. So think if you have a single variable and your set is greater than 0, then this should belong to the set if you give it a variable that's greater than 0, trivially. And so it's very interesting if you have your solver manipulating MathOptInterface objects, or if you want as a user to query this information of, do I have this point already in my feasible set or not? So if yes, then I don't know, I can continue with something feasible, otherwise I'm not feasible and I need to do something else, and so on. So it's basically some needs that arose from some research specific, topics from my research, and other people have had the need too. So yeah, this pull request was deemed to be valuable for the whole ecosystem. And from set belonging, it went on to being a pull request about set distance to set. So trivially, if you have your point, which is in the set, so it's feasible, your distance is 0. Otherwise, if your point is outside the set, you should be able to give the user a distance or a sense of a distance that gives it how infeasible you are with respect to this set. Alright, yeah, so if I guess I can open the pull request on the side, so that looks like this. So it's now still infeasible. I started it, and there was a lot of discussion about this pull request because, well, how to evaluate some sets is really non-trivial in some cases. So it was mostly about discussion. So it's in the MathOptInterface repo on GitHub, and yeah, it started on February the 11th. Great. So, and yeah, we'll try to get this done. I don't know, but at least moved forward in the next hour, few hours. I don't know. So first thing I did was get my repo working. I'm gonna get back master. No, not that. I'm gonna keep the chat on the side. If you have questions all along, don't hesitate to ask stuff. Otherwise, I'll just keep rolling with it. So, did I pull master? I think yes. Count set. So I haven't pulled master in a long time, so it might break. No, it's merging. Wonderful. Okay, so we now have eval set here. So the thing I wanted to do is the whole PR is in this sets file here, and what it adds is basically no, not dual sets, distance to set, yeah, this function here. So we add a function distance to set, which evaluates the distance from the point V, or from the value V, to the set S. If V is in S, then the distance is 0, otherwise you give it a meaningful sense of a distance. What we have now is distance set V and S. What has been discussed is adding a type that's going to define which distance you use, which type of distance, because different solvers will have different meaningful distances, and we'll add a default distance, which is the L2 norm in most cases, and otherwise solvers will be able to define their own distance type, and they will have to implement this distance to set function for the type. So this means we need to modify this here to add distance definition, I don't know, something like that. So we need something here. VS. So abstract type, we'll add an abstract type, sorry. Distance function. And we'll document this later. Oops. And this will be so this will be distance definition. Distance function used to evaluate distance from a point to a set. And we'll add our default distance, which is a subtype of this distance function. So what we had now was just the same thing without anything about the distance. We had just one up to now in this PR, but for the moment there's nothing in MathOptInterface itself. So this and L2 norm, PD in distance, default distance function uses the Euclidean distance. So one bad thing we have is if somebody implements a new distance, they need to re-implement all these for the standard sets, and if someone implements a new set, they need to implement this distance to set function. So it's maybe not ideal, but for the moment I guess it's a good starting design. Each set implements which has to be a distance function, vt with t the appropriate type, for values of the input space. Yeah, good enough. For members of a set, yeah, better. Okay. So we now have a distance to set function, and we need to basically add this default distance everywhere in all the distance to set implementations. It's not too bad. We'll see. Yep. Yeah, no, not that. Okay, here. So most of these distances really make sense. For example, for the interval set, you have a distance of 0 if your point is between the lower and upper bound. Otherwise, you compute the maximum of the two, because it's either not in the set because it's either too big or too slow or too low. In that case, you just compute the maximum of this, and then you compute the maximum of either the lower bound minus the value if it's too low, the value minus the upper bound if it's too big, and 0 if it's between the two. Wait. No, yeah. Distance to set for infinity norm. So the big difficulty here is that the sets defined in MathOptInterface are not all convex, and they don't all come from convex optimization or, let's say, geometrical optimization. Some of it is, for example, from constraint programming, and you don't have a very sensible definition for set in for what is in the set. Is, well, that's fine, but how do you define the distance between a point and the SOS2 set, for example? That's a very bizarre way of thinking about it. So it's not always defined, but the discussion ended up being, well, we'll just try to have something meaningful enough. So yeah, sadly I didn't start this with streams, so we have something that's already going on with distance to set implementation. But at the same time, the beginning for this PR was so messy, I don't think a stream would have been that relevant. It would just have been me mumbling and wondering what's going on and how do I do this or that. Alright, so that was the easy part, I guess. It's really weird to have an abstraction with um, sorry, it's really weird to have this abstraction of having an abstract distance and a default distance while we don't implement anything differently. So yeah, it's a bit of a dangerous pattern of over abstracting for nothing if you don't have a real abstraction with multiple things. But at the same time, I don't think I have another meaningful distance to offer here, and this would be too much work anyway, so the best thing would be to leave it as is, and at some point some solvers, for example conic optimization solvers, will have a different definition of distance for some sets, and then it um, will be able to compare the distance and implement a new distance for these solvers. Yeah, I don't think I have touched any of the matrix sets. Just too tricky for the beginning. Yeah, integer is really weird for some of the things. For distance to an integer set, it's the closest point of the lattice, I guess. But for some of it is just very bizarre. For example, yeah, semi integer is an interesting case because it's either 0 or something between a lower and upper bound. But in that case, you have to compute. You have two things, or consider the union of the set of a singleton and in this interval, compute the closest one. I'm not sure how this scales to higher dimensions, by the way. And SOS is really, so SOS special order sets 1 and 2 are really the weirdest ones. Distance to set SOS1, okay, yeah. And SOS2, did I even do it? No, I don't think I did it because I couldn't find any definition of a distance to SOS2 which made sense. Indicator is another weird one. So I've written about indicator sets before, and yeah, indicator sets are a set where there's a binary variable 0 or 1, and if it's one of the two values, it activates another constraint. So if y is equal to 1, then this other constraint has to hold, for example. And the distance to an indicator set is very weird because you have either, so you can bean the set by either deactivating the binary or by activating or by respecting the activated constraint. So that's what is the closest? You don't know. You're just comparing potatoes and apples. Distance to set. Yeah, so we just not even scaling or anything. Oh yeah. I think I need to propagate the distance here. Complements is another interesting one. I'm not sure it's easier in any sense. Yeah, I'm not sure this is any easier, but at least it's, let's say, in the continuous optimization world more. Um, so how is it defined here? Yeah, it's about complementarity constraints. There. At least the documentation for this one is really great. Did I add a distance already? Maybe we could do that. So we could separate functions. Update dimension. What is that? Okay, no, yeah. So we don't have a meaningful distance for complementarity sets yet. Maybe we should add one. Good question. So at least we have we did add all the things we needed. So all the default distances everywhere. So I think we can maybe try to run the tests, see if we basically broke something or have an open and not close bracket or anything like that. Oh, cold coffee. In the meantime, if you have some questions on MathOptInterface itself, I guess I can try to answer some. I'm contributing sometimes, but really not that often, and I haven't been involved with most components of it, but I can answer some few things on it. Time for the test to run. Yeah. Oh, wow. Yikes. Oh, it's still rolling. What on earth did I do? Okay. Let's get this. What happened? Got accept. Run. What? Package test not found in the current. How is that the problem here? Oh, okay, cool. So we added some tests the last time on it. So that's a good point. We added some tests. We broke them because we changed the signature here. So distance to set is for the moment taking just the point and the set, and we have to add this this default distance. Right, so good thing. So we'll keep the source open here. Let's open the test in parallel in uh, set distances, yes. I guess we can just replace things here. I added a command line utility, not said, like said, but that I can understand. What was it? I think it's in my cargo. No, cargo. Yes, bin. Which one is it? SD. Yes. How do I use that? Okay. Smaller. So. Yes, so I guess the first thing is we'll do a preview. I don't want to break everything now. So first argument is, yes, also that s. First argument will be my default distance something. And that's in, we're going to test for that. sd dash I, no, dash s dash p. So I think I don't need to escape the parentheses here because I'm in string mode, so it's not gonna take a regex. So that's the find, and then the replace will be something like, well, the same thing basically. Default distance, like that. Okay. Yeah, I think I need to escape the parentheses. I broke it. Yeah, is it expecting something else? Yeah, I think so. So, I need to escape some few things, namely all the parentheses, I assume. Maybe better like that. Huh? No. So, how does this... Yeah, first argument, second argument, I don't think it's... Oh. Okay, it's currently reading from std in. Cool, cool. Yeah, so I need to give it the files, which is set distance. Good to know. Always read the manual. Is it highlighting? Okay, no. So now I don't think I need to escape the parentheses. So this is fine. This is fine. Here too. Okay. Okay, cool. So this is the preview of what it will give if I run it. This preview feature is really nice because I tend to break everything using find and replace command lines. So that's really neat. So we don't need the preview. I think this is correct. I'm satisfied with the result, so I can just run this. And this will replace my setDistances.jl file with a new version. Okay. And now I can rerun my test. The file has changed. Reload, yes. Oh, and no. Diff tests. Okay, no, cool. Perfect. So let's rerun the test now. I hope I didn't break too many things. Okay, things are starting to pass, so it's a good sign already. So one really open question, maybe I should document this somewhere before I forgot, is we are basically breaking dispatch a bit, because we are dispatching both on the set and on the distance. So the question is, how do you extend this system? If you have a new set, do you need to implement it only for the default distance? And if you have a new distance, do you need to implement everything, or can you use a fallback? I guess you can use a fallback, yes. Okay. Questions. I just added to extend distance system. Do we need a fallback for a new distance to the default one? To extend sets, do you extend only the default distance? There we go. So we can keep this and put it as a question on the PR to discuss with the jump community. In the meantime, this is still running. Oh, benchmarks. Oh, I didn't change the name of streams. This is still written hikes, which was, by the way, a catastrophic stream. I didn't get anything working. Oh, regression, not good. Oh, no, I don't think this is relevant here. So, title of a stream. This will be face contribution, MathOptInterface, distance to set evaluation. Stream language, broken English, still the case. Tag, programming, software development, yes. Science technology, yeah, sounds about right. Alright, and yeah, I guess same thing on the YouTube channel. This is not the correct one. So if you saw the title of the stream, so Hikes is a solver for linear optimization, and I was working a bit on the wrapper from the solver, the native C solver, to a Julia package usable directly in Jump. Alright, the tests seem not to be protesting too much. Okay. Right. So yeah, in the meantime, if you have questions to ask, curiosity on some of the things we're doing, I guess I could add my question now. This can go back one level. Micro questions here. Open questions for distance to set. Distances to set. Right, so we can close that. We don't have that many modifications. Yeah, questions is not a big deal. We didn't modify project, I think. A tunnel. Oh no, it's just line ending. Okay. So these all have been added to evaluate if some PRs are adding some overhead or slowdown on some standard benchmarks, because we don't want MathOptInterface to be slowing down the resolution process. It can be a bit slower on compilation or anything, but we don't want to get things too slow for the users. Otherwise, it would be a counter argument to use MathOptInterface versus the solver directly, and we don't want that. I should stop drinking that. Okay, well, I guess this all looks good. I'll not wait for all of it to be testing. I'll check what tests we had before. Um, Maybe one thing we should do is add a new kind of test. So set distances. Okay. We could add another kind of test where we define a new distance, a dummy distance, and just check that the values are different. For example, taking the same block as this one, non-default distance, and we don't need to add 2 levels of test set, I think. Maybe we should set the random, I don't know. I'm not sure I can evaluate at the in a test set, so I need to do things in the top level here. So struct, that will be dummy distance, which is a subtype of my that abstract distance. Yeah, that's how we defined it, right? Abstract distance. Distance, no. Distance function. Yeah, I think it's better than abstract distance. So we have our dummy distance and distance to sets. I guess we need to so we shouldn't mess things up. Let's say that to test our indirection system, my distance to sets of dummy distance vs is equal to the same thing with our default distance and since the distance is a scalar, we're just divided by 2. That's quite a hack. And here we'll test that this is so we'll just test for all of the sets for S in, so that would be my reals, my zeros, my non-negative. So for all of these, I'll copy after, but we want to test that. So the distance to set of default distance is approximately equal to 2 times the distance to set of the dummy distance. I think that's correct. So I added non-negative, not non-positive yet, we need that too. And that's it. And we can also test that for minus v. Alright, and new line. Ugh, what is that again? Yeah, this is definitely not my problem. This is somewhere in some of the tests that I should not be touching and that I'm not touching. So right. Oh, we have some module problems here. So what I want to do here is just include some of the tests, which is namely this file, test set distance. Wait, what? Nope, it's supposed to be finished. Include test set distances. Nope, n not defined. Alright, yeah, what was n? Let's see our initial example. Okay. I don't think we need too many tests here. Let's say n equals 3 and be done with it. For n in 1, 3. So at least we have a case with n equal 1. Let's see. Nope. Dummy distance not defined. Is it not now? Oh no, it's defined here, it's not in MY. That's totally correct. Okay, perfect. So default distance. No, not origin, sorry, we want fork. Okay. Well, I think we're close to having things finished here. Yeah, the only thing remaining, I posted the questions, so we don't need it. Maybe we should check if we maybe some of the distances should be added. Some of the distances that we did not add yet should be added. So that will be in the conic, the matrix conic sets, I think. All of these are covered. Interval 2. Norm infinity is fine. Distance to set, geometric mean, okay. Maybe I should check if I had some comments that were not responded to in the review. Yeah, maybe abstract distance would be more, let's say, more consistent with the rest of MathOptInterface of the package. So this means replacing here our abstract type distance functions by abstract distance. New distance subtypes of let's implement fallbacks for sets they don't cover. And implement distance to sets distance VT for sets they override the distance for. Is this I think the Unicode is not wonderfully rendered. No, that's fine. No, yeah, here it's HTS implements at least default distance with T. Okay. So we need to fix this, and the tests is specifically this one here is now abstract distance. Okay. Yeah, I think we're all good here. And now check maybe for some others if we have some meaningful distances that we would like to add here that are not yet there. So the complement set is an interesting one, because what is the distance to a complement set? It's either so we could take the L2 norm of, I'm not sure it's that meaningful, but we consider that x here is bounded, so it will be the L2 norm of the distance between the distance of xi in the bounds and the function in the corresponding set. I think that it does make sense. So the sum of the 2 squared and square root. Classically, the bounding set xi is okay. Yeah, that sounds sensible. So this will be distance to set with our favorite default distance value, which will be a vector, and complements. So complements only give us, complements only gives, it's with is yeah, singular plural. Complements only gives us the dimension, and the rest of the information should be in V itself. So first thing to do is check dimension between V and S. So check dimension, okay. Okay, it's a bit disturbing here because complements depends on its context, and that's a bit of a bother. Here you see the example is x is in interval -1, 1, and then the complement is given by this, but this in complements does not really exist by itself. It depends on the bounds of x. And I'm not sure we can get back this information. Yeah, because a variable doesn't have a variable itself doesn't have a bound. It's the solver of the optimizer which stores the bounds of a variable. Yeah, I don't think we can do it because of that. It's a bit of a bummer. I'm a bit frustrated not to have a good solution for this. But to compute the distance, we would need this this additional info of what are the bounds. Yeah, this is not great. So there's this single variable in I plus dimension, and for this we need this f of I plus dimension to give us its bound, which we don't have. Yeah, that's really not great. We could always assume the distance is using this classical bound. Yeah, I think this is the only thing we can do here. Assume that the variable is just bounded by mean greater than 0. And I'm not sure there would be any more elegant solution to do that. This could be storing in the complementarity function itself, in the complementarity set, the bounds that are implied. Yeah, this will be more self-contained because this complementarity depends on the context and on the global state of the model, which is not great. In any case, we could go for a moment with assuming xi is just positive. So this here just checks the dimension and will error out and bubble up an error if we have the dimension not fitting between the vector and the set. And then we would add residuals equals for I in dimension of the vector. Yes. No, of the set, sorry. No, it's the dimension. And here that will be we need at least one of them to be 0 between the xi and so non-positives. Avoided distance to set with let's just propagate the default distance vi and greater than 0. Oh. Okay, so we're supposed to have everything at 0 here. Comp distance. So we're iterating twice here, but I'm not gonna take care of optimizing the code for a moment. So we need max of 0. No, we need the minimum of, sorry, distance to set and no MY, because we are in MY right now. Distance to set of D, MY dot zeros equal to 0 for so that's the set, and sorry, the vector here is vi. Hi, so what is MathOptInterface? I'm just finishing this line and I'll answer right away. So we need the minimum of the distance to set vi equal to 0, or the function equal to 0, I think. Yes. So the function has to be greater than 0 in all cases. And here non-positive var, non-positive func, and com distance. So minimum of distance to set 0, and so that's for a variable, and then the function I plus s dot dimension. Okay, and then linear algebra dot norm2, which is our convention for the default distance of. So this is awfully inefficient for now. Plus this, plus that. And this is our return. Okay. Now, so the question is, I'll just repost it for to propagate it on, to broadcast it on both Twitch and YouTube. So what is MathOptInterface? So if you're using jump dev, if you're using jump, no, I want the code. Oh, it's not there yet. Okay. Opt jump. So if you're doing constraint optimization in Julia, there's lots of chances you're using jump. And jump is, let's say, a domain-specific language for constraint optimization. Now, jump is mostly about the syntax and how you specify your problems. What's behind it is another package called MathOptInterface, which is this folk here. And MathOptInterface is basically the backbone of this of jump. So you use it to define a set, a constraint, a variable, and so on. And the goal is for MathOptInterface to be very simple to bridge to for solvers, for native solvers that are not always Julia based. So yeah, MathOptInterface is mostly what you work on when you're on the background side, on the backend side. You're working on the syntax, on how users enter their problems, specify their problems. This is mostly on the jump side. Yeah. I hope that answers the question. So yeah, I'm working on MathOptInterface now because I'm working on more, let's say, foundational things or behind the curtain things, which are defining sets, set distances for points, and so on. And once this is defined, people in Jump will be able to use it, or solvers. I think this will be mostly for solvers. Will be to use it to say, okay, is this point feasible or not, and how far am I from my feasible region? So yeah, I hope this answers the question. Otherwise, feel free to ask. So I have my new distance to set here with complements. I think I just add a warning here. Warning only works for conventional, for how do we call it? Classical, yes. Complements, constraints. Only works for classical complementary constraints, and that would be something like xi 0. I'll just copy that. So and that would be f I of x. Okay, yeah, just to add a fair warning that we're not doing this for the general case that's been specified above of very general, let's say, complementary constraints. Question. Okay, so if I had a nonlinear optimizer running on a hyperbox constraints, yeah, okay, would MY be a good place to tie to? Yes, absolutely. I had a couple of streams on how to work with native C native solver and how to plug it onto MathOptInterface. So if you have a solver, you don't want to plug it onto Jump because Jump is mostly the user-facing side. You want to plug it onto MathOptInterface, which is way easier to do. You just have to define the type of constraints you support, so which functions and so on. So basically, how this thing is specified is MathOptInterface works with function of variables in set type of constraints. If your function is very non-linear and you can take absolutely anything, yeah, then maybe I'm not sure this will be the best place to put it. I think you might have to play with some jump things directly, not only MathOptInterface. If you really have absolutely any nonlinear function. But otherwise, if you have a linear function with structure, let's say, for example, you support conic constraints or quadratic constraints and so on, then this will be MathOptInterface is what you're looking for. Implementation of a direct algorithm in Julia. I'm not sure, and I've seen it, but I don't remember what the direct algorithm is. So, okay, so the only info on the function is that it's continuous. I think in that case this will be on the jump side, but I don't want to say anything stupid. for change. So the best place might be IPOpt as an example, because IPOpt does support nonlinear functions, arbitrary nonlinear functions, I think. And so you might be able to check here if they're just defining it in terms of MY or also jump. Yeah, I don't see any jump in the dependencies. No, only MY. So you might be able to do nonlinear only with MathOptInterface itself. And worst thing, well, in the worst case, but best thing, let's say, if your solver supports things that are not implemented in MathOptInterface, you can define it yourself. So again, we said that the abstractions of the constraints are function of something in set of something. So if you support some functions in or some types of objective functions that are not implemented in MathOptInterface, you can just define your own and just let the user plug it. So in any case, you won't be limited on that. You can just extend with new functions and say, I support my custom objective, which is an arbitrary continuous function, and you can go with that. Yeah. So I don't think you will be blocked by using my MathOptInterface. It would be simpler than using jump for defining your solver. So yeah, again, you can define your custom type of objective and constraint, but in that case, your constraints are, you said, only hyperboxes, and for that case, you can just use the less than, greater than, and interval. So with these three constraints, you have all the things you support, and then you support arbitrary objectives. Right, so I think we're good here. We need to implement tests for this, and this will be clunky. Oh, nope. Question: do you know why Julian solvers Optim and Blackopt are not hooked into MY? So Optim is already a different framework. Optim is mostly about continuous unconstrained optimization. So maybe for the direct algorithm, it might be. I'm just going to repose the question. But yeah, Optim is mostly about unconstrained optimization and with very basic types of constraints like boxes, like you mentioned. So now that you mention it, maybe the direct algorithm would be more adapted into the Julia NL solvers ecosystem or Julia smooth optimizers, which is smooth optimizers. This one, which is from the very basis about nonlinear, arbitrary, continuous, differentiable nonlinear functions. So it might be more adapted to plug a new solver onto that. And why they are not plugged onto this? So basically, Optim.jl and BlackboxOptim.jl were both there before MathOptInterface, and they were not designed with this kind of use case in mind. They're mostly about hard functions, but just one objective function, and you try to find your minimum. They're not that much, and yeah, MathOptInterface is really good for specific structures, I'd say, like specific structure of your feasible set, and so on. Like formulating the problem is the big business, I'd say, more than solving it, but that's a very approximative way of saying that. So, yes, default distance. So we have something now. Yep, you're welcome. Let's say test set complementarity. Complements. So MY. So we're trying to compute the default distance for a given vector and with complements. say 1, no, 2, 2 to 10. Do we need even numbers here? I'm not sure. So what I want to do here is, so first compute my first, and so I'm going to create the values, which will be append so first the VI values, VI, and then after the VI's the F of X I's, Fi of X. Alright, let's say X if we're trying to keep consistent. Okay, so append. So this will be here. So let's say we first have x's equal rand of n, and f's equal rand of n. So normally here we have a positive distance. That's wrong. So vcat, so we just concatenate the two, so the x's and the f's. So the default distance, complements, and then that's going to be n. Yes. So test, and this will be greater than 0 in any case, because we're picking random numbers between 0 and 1 uniformly distributed, so will almost never have 0. And we're supposed to have either for one index, we're supposed to have either the xi equals 0 or the fi of x equals 0. So this is wrong. Okay. Then we're gonna set all of the x's to zeros. No, equals 0. Element wise. And the f don't move. And then this has to be approximately 0 with a good tolerance. Oh well, why did I need something so high here? Okay, so given that all the x's are 0 here, we're supposed to have something good. Then let's say f's equal, no, x is equal to f's. Oh wait, yeah, this is copying here. Trivial x's f's. Trivial x. So this will be 0 because we have all the x's being 0 and the f's being positive, so we're fine. Then the x equal f's, and the f's are set to 0. And again, this should be fine. I need this one completely. Oops. Wait, what? Ah. F. Okay. Then we need it to be non-zero if one of the x's is negative. Let's say x1 equal -1. No, we can just change directly this one. x1 equal -1. And then this has to be greater than 0 now. Okay. What is that? Whoops. Nope. Diff. Okay. And include the test file. In the meantime, my awful cold coffee is finished. I guess I'm gonna get some water. Oops. Distance function not defined, of course. Where did I use distance function directly? Oops, abstract distance. No, not here. SRC sets 95. Oh, yeah, of course. Better. So in the meantime, I'm gonna fetch some water. Alright, yeah. Best thing ever is to come back and get errors. method matching distance sets default distance. And where would that be? Closest candidates, and that's happening here. Oh, of course. The parenthesis is not supposed to be there, but here. Did I do the same thing somewhere else? No. This looks fine. So. So let's relaunch the test now. Right, no. We need to completely reopen the thing. The good thing is we didn't break anything, because the rest of the tests are still green, I guess. Still get some good news. Nope. So what's going on now? I not defined. Did I? Oh. Oh, I think it's in the source. Complements. Distance to sets for, so I defined here for sure. Oh wait, I didn't. Yep, absolutely. For I in. Oh yep. 1 2 s dot dimension, and not just this was an error here also. And so we modify the test, so we need to relaunch things. Oops. What's going on now? Oh, I still have one of these. Distance to sets, stack trace. Here. Distance to sets, this, that. Oh. Yep, same problem. The value and the sets. Okay, and this is closing the minimum. And that was in the source, so yes, quit. No. values, of course. Where is that? Set distance 132 in tests. Do I have a test open? Yeah. 132. Abstract distance seems fine. Oh, did I not say that? Okay, wonderful. Things are passing. So I think we still need to document what's going on with the complementarity sets. Microcomp bug elements dist bug txt complements access to variable bounds. If given vector of values is in the complement, respects the complementarity constraints. A possible fix will be accessing a possible fix would be accessing the English variable bound in a generic way, which is really not great. Another will be specify complementarity with the bounds. Complementarity vector of struct sets. So, yeah, another one will be complementarity with bound. Be to specify complementarity constraints with the associated bounds. Last one will be to no, I don't have a last one for now. Okay, so I think we have it. Tests are passing, we're happy. I think I committed before, I hope. Nope, and this is all one big commit. So that would be default abstract and default distance for sets, added complementarity and dummy test distance for eval set. Right. Yeah. Except if we have additional questions, I don't think we should push this much more forward. We have things we need in place. I'll probably just post this as a bug or in the discussion maybe. Yeah. Yeah. If we don't have many more questions, maybe. Yeah. I think I'll close this soon. I'll check the discussion. So yeah, we don't need that. New comment here. Okay, so I guess I don't think I will stream the whole discussion here. Just post this point on complementarity constraints. Issue comes from complementarity. So MY complements, just types it this correctly. Which is not possible. Current signature. Right, I think that's it. Okay. So the basic thing we did here is fix some issues with distances. So soon with this we'll have the possibility, given a MOI set and a given value, to say either, well, if this point is in the set or not, first thing, and if it's not in the set, we'll have some sense of how far this point is from the set itself. So if you have 2 points and one is lower in distance, it should be closer to being feasible than a point that's not, that has a greater distance, let's say. But yeah, complementarity is a bit of a bother here. I'm not sure how we'll tackle that. That's a bit of an open discussion. It's a problem because, yeah, complements as defined here, I'll also type this correctly. Complements as defined now needs an implicit context of variable bounds, which we don't have. So maybe this is where the issue comes from, and if we have the issue for our set distance function, then we'll also have the issue for other things at some point, if we want to have self-contained constraints of function in set. So yeah, I guess I leave it here, and yeah, I think we can. So I can quit that. Whoop. Yeah, I just had this last thing, and I posted it, so I don't need it anymore. And I think we can stop the stream now. So yeah, take care, everyone. Thanks for the question, feedback, and discussion. And yeah, I hope I see you soon. If you have questions or things you want to ask, well, yeah, that's called a question. But if you have some other things or maybe some topics you want to have, don't hesitate to ping me on Twitter. So that's Matt, but also twitter.com/Matt. Yeah, that one. So yeah, either on Twitter or GitHub if you have something specific to open source or anything like that. Right. So yeah, I'll be finishing this. Yeah, no, I'll be closing this now.